looked cubic, but it wasn't. It had like some, we'll just say, gosh, up and down. What did I call that yesterday? I called that peaks and valleys. Oh, and it does not have that. Okay, so it's not like it's going up and down like yesterday. All right, so now that right here is the equation to what you see at the top. So if you see that at the top, we need to give the domain and range. Find the y-intercept, find the absolute max, and find the absolute min. How do we do that? First, you're going to have to look at it and look at your domain. So if we were to do that, this whole line is your domain. I want you to notice, though, that all real numbers it looks like, but what do you notice? Like, so I'm going to draw this line right here. It looks like those arrows are getting really close to that line, but they never actually are going to touch. So that is the value, it looks like, of 2. So it's actually never going to touch 2. Let's see if they said that. Yeah. So right here, when they say all real values, that's true, but it's just never going to actually touch that 2. It's going to get really close, but it won't. Okay, so now let's look at the range. Let me erase this. Okay, so the range is going to be this one right here. So look up and down. Notice all these values up here are going to get touched, it looks like. But right here, it actually never touches the x-axis or goes below. So it will never go down here, and it never touches that. So how do you write a range that is only above the 0 but not inclusive to? Okay, there you go. So let me color code it. All real values of y, it will be, but they have to be above 0, and they can't be inclusive to 0. All right, so make sure that you understand. Write this, not inclusive. Okay, that is called an asymptote. Whenever you look at that, it is a line that is going to be an exponential line, it looks like. So this is like exponential because of that 2, basically. But an exponential line will always have like that curve, and it always gets really close to something, like right here, but it just never actually touches. Never will touch. Okay, which is called an asymptote. All right. Well, you actually don't need to know that word until Algebra 2, but I always teach things ahead of time. All right, now we're going to try these. Oh, wait, did I answer min and max? I don't think I did. It says, what's the absolute max? What's the absolute min? Okay, I'm going to tell you there is none. Because do you know how high this goes? No. And do you know how low this goes? Actually, no. You know it never is actually going to get lower than 0 or inclusive to 0, but those numbers can just, I'm telling you, infinitely get smaller and smaller and smaller. So there's no absolute here. Because it's not a line segment, I don't know where it actually stops. Okay, moving on. Try these A. Look at that. Okay, this is graphed here. Okay, so today, in a minute, I am going to insert a video into this video that actually shows you how to graph in your calculator. Some of y'all may know how to do this, but I'm going to show you. I've got to show you how to graph an equation in your calculator, and I'm going to show you how to do a table. Okay, so that way you can look at your domain, you can look at your ranges. I think today the best thing for you will be the graph, but I'll show you both. Okay, so here's your graph. Identify your domain and range of the function. Let's start with domain. I need you to highlight it. All right, so if you were looking at that, I need you to notice, one, this is not a line segment, so it's never going to stop. So these little arrows right here are going to continue on like forever. And so, none. Oh, I didn't mean that. I meant, oh gosh, did not mean that. I meant that for something else. Okay, I was thinking something else. All right, here, what I mean is, I'll set notation, do the little squiggle, all real numbers. We don't have any that are not going to be here. All right, so range, let me color code. Let me erase this line. So if you're looking at your range, it's right here, so up and down. I do see a stopping point, and I need you to mark it. It's right there at the 9, but everywhere else is continuous, so how do you write that range? All right, so you're going to do all real values again. But of y, and do this little colon because there is a stipulation to the y, because the y has to be less than or equal to 9. All right, so it can't go above 9. 9's the highest you can go, but it can be inclusive to that squiggle end. Okay, identify the y-intercept. So if you're looking, where does it cross the actual y-axis? Let's see, right there. So you're just going to say in coordinate point form, 0, 8. Identify any relative or absolute minimum. So just look, where are the lowest places that this thing can go? And that's what I was actually thinking about a while ago because I did those arrows. What is the lowest point we can go? There's not really one. So you're just going to write none because it goes on forever. Any relative maxes. Okay, so we can talk about this in the fact that the highest point it will go is a 9. Or 0, 9, and understand that that is a relative, but it's also the absolute. So this is that situation where the sometimes came into play yesterday. Okay, now let's go to the next page. Okay, so once again, here is your equation. Here is your graph. In a minute, I'm going to insert a video showing you how in your calculators to do a graph. Otherwise, you're just going to have to sketch it out and make your own tables. But I didn't think you would want to do that. We need to learn how to do them in our calculators. Okay, so identify the domain and range. Look at your domain. I want you to go ahead and try to fill that out. Domain and range without me. Okay. Yeah, that was a trick. Okay, so the domain is inclusive of everything. That's not a line segment, so you just say all real numbers and set notation and color code. What about the range? That's going up and down. It doesn't stop either. This one is also all real numbers. There's no end. So what is the y-intercept? Well, I can find that. That's for sure. So right there, just write it in a point form because that's your input-output. Any relative or absolute mins or relative absolute maxes. Well, let's go ahead and talk about that because there aren't any because it doesn't stop. So nowhere is going to help me here. Explain whether this equation represents a function. Okay, so you could figure out several things here, but yes, it is. You could say because the exponent is only a 1 here for the input. When you have an exponent of 1, it will always be a function. You could have said line test, vertical line test, or you could have even said that because there's only one input per output. All right, so now let's go here. Once again, in your calculators in a minute, you're going to have to be able to punch that in and get a graph. Here's your graph given to you, though. I want you to go ahead and identify the domain and range. Okay, your domain, this is not a line segment. I see arrows. It goes on forever for those X's. I see no stopping. So we are going to say all real numbers, but the range. Let me erase this. Okay, so let's look at the range. This one would be that tricky kind because, oh my gosh, it looks like it touches. But because I know what this is, I know this is an exponential graph. I know it's going to have that asymptote situation. Then, therefore, the range is going to have a stipulation. So what I'm going to write, let's see, all real values of y, but there's a stipulation. What about y? y has to be greater than, not equal to 0, and end it. Set notation. Okay, what is the y-intercept of the function? Let's see, where does it cross? Please write that as a coordinate point. And let's see, next page. And I'm just going to have to kind of go back and forth. I'm going to leave in my book so I can see it. So I'll just answer these. You just be looking in your book. What is the relative or absolute means? Okay, so what is the lowest point that it can go? Do we actually know how low it can go? No, because right here it can go smaller and smaller and smaller. I just know it never touches 0. So I need you to write none. Okay. And what about relative or absolute maxes? Once again, there's a problem. It goes on and on and on. I don't know how tall it goes. So I really don't know the maxes or the mins. Now, this is that calculator part. So I'm going to insert a video showing you how to do your calculator, and then you're going to enter all of these functions into your calculator, and then we will check them together. Okay, so check your answers right here. The domain and range was matched right here at the bottom. So check those out. Then I need you to come over here and circle your math tip. And this is the example. So sorry, guys. This is the example we did in example A on page 87. So if you're looking at this, a restricted domain means, or any kind of restriction is going to be because it turns out to be, okay, there's undefined, 0, positive, defined. Sorry, I can't talk and spell. Okay, so it can be undefined, 0, positive, or negative. So once again, this means undefined. I don't know if they say that word. I don't think they do. So I want you to write that word there. Okay, so what would be a restricted domain that I cannot input into this equation because it would cause it to be undefined? The answer is 2. X cannot be 2. That is called the restricted domain. Draw another arrow. Y. So let's write it. 1 over, let me replace it, 2 minus 2 squared. And 2 minus 2 results in a 0. So this would become 0 squared. And what's 0 squared? 0 times 0 is 0. 1 over 0, will that work? No.